In today's video, we will be discussing about mathematical induction, right? So what is mathematical induction? It is a way to prove that a statement Pn is true for all positive integers, right? A statement Pn is true for all positive integers, right? So how you will prove it? Step 1. We will show that P1 or P0 is true. Step 2. We will assume P of k to be true, and then we will prove P of k plus 1 is also true, right? So first we have to prove sum of n natural integers is n into n plus 1 by 2, right? So now for n is equal to 1, LHS we will have 1 and RHS I will have 1 into 2 by 2, that is 1, right? So for n is equal to 1, this holds true, and we will assume that P of k 1 plus 2 plus up to k will give k into k plus 1 by 2. This is also true. Now for P of k plus 1, I will have the same thing, but then k plus 1 here. So this I will use inductive hypothesis. So here I will get k into k plus 1 by 2, and then I will add this. So after adding, I will get k into 1 plus into k plus 2, k plus 1 into k plus 2 by 2. Therefore, Pn is true for all integer n, right? This is proof. Now next question is n into n square minus 1. I have to prove is divisible by 3, right? For all positive integer n. So for n is equal to 1, I will get 0, and this is divisible by 3. For n is equal to 2, I will get 2 into 4 minus 1, that is 3, is equal to 6. This is also divisible by 3. Now I will assume P of k plus 1 is equal to k plus 1 into k plus 1 square minus 1, right? So I will get ultimately k plus 1 cube minus k plus 1, and this I will ultimately get k cube minus k plus 3k square plus 3k. So this is divisible by 3. This is already divisible by 3. We will use here inductive hypothesis, right? And this whole will be divisible by 3, hence proved, right? Now next question is, we have to prove 7 to the power n plus 2 plus 8 to the power 2n plus 1 is divisible by 67. So for n is equal to 1, this holds true, that is 7 cube plus 8 cube is equal to 343 plus 512 is equal to 855, which is divisible by 57, right? Now P of k plus 1 will be 7 of k plus 3 plus 8 of 2k plus 3, right? Now I will write this as 7 into 7 to the power k plus 2 plus 8 square to the power 8 to the power 2k plus 1, 8 square into 8 to the power 2k plus 1. This I can write this as 57 plus 7, 64 I can write as 57 plus 7. So this multiply 8 to the power 2k plus 1, this multiply 8 to the power 2k plus 1 plus 7 to the power k plus 2, right? Now this and this I will club. I will get 7 to the power k plus 2 plus 8 to the power 2k plus 1. This is divisible by 57. using inductive hypothesis, and this is already divisible by 57, hence proved. Now next one is an is equal to 2 to the power n plus 3 to the power n. A0 is 2, A1 is 5 given. Now I have to prove an is equal to 5 an minus 1 plus minus 6 an minus 2. So I will assume for all n less than equal to k, ak will be equal to 5 ak minus 1 minus 6 ak minus 2, and then I will simply, for k minus 1, it will be right. Right, I will simply add here plus 1, so 5 a k minus 1 plus 1, and then 6 a k minus 2 plus 1 will give me 5 a k minus 6 a k minus 1, right. This will give me a k, I can write it as 5 into 5 a k minus 1 minus 6 a k minus 2 minus 6 a k minus 1, right. So overall I will get 19 a k minus 1 minus 30 a k minus 2. So this I can write it as 19, I will write this as 2 to the power k minus 1 plus 3 to the power k minus 1 minus 30, 2 to the power k minus 2 plus 3 to the power k minus 2, right. So this I can write it as 38 by 4 2 to the power k plus 57 by 9 3 to the power k minus 30 by 4 a to the power k minus 30 by 9 3 to the power k, right. So this will be written as 2 into 2 to the power k plus 3 into 3 to the power k, and 2 to the power k plus 1 plus 3 to the power k plus 1 will be hence proved, right. This is also called strong induction method, right. Now I am going to solve next question. Now next question is given a1 is equal to 1, a2 is equal to 2, a3 is equal to 3, and an plus 3 is equal to an plus 2 plus an minus 1 plus an, and I have to prove an is less than 2 to the power n, right? So a4 is equal to a3 plus a2 plus a1, that is 6 less than 2 to the power 4, which will be my basis. And now I will assume for pk an is less than 2 to the power n, right? So ak plus 1 will give me is equal to ak plus ak minus 1 plus ak minus 2. This should be less than 2 to the power k plus 2 to the power k minus 1 plus 2 to the power k minus 2 is equal to 2 to the power k minus 2 into 4 plus 2 plus 1, that is 7. So 2 to the power k minus 2 into 7. Right, now 2 to the power k minus 2 into 7 is less than 2 to the power k minus 2 to the power 3. Right, this is true, that is 2 to the power k plus 1 ultimately. So ak plus 1 is less than 2 to the power k plus 1. Right, now next thing we will discuss is logic and satisfiability. Right, so there are normal connectives, that is and, or, negation. A set of connectives is functionally complete if every compound proposition can be expressed using only those connectives. So using only these three connectives, I can express any compound propositions. That is, I can only use these pairs. Only using these pairs I can express any compound propositions. Now, satisfiable. There exist some truth values of variables that make it true, and unsatisfiable means there are no truth value of variables that make it true. Right. Suppose I have P and Q. For P I have true, true, false, false, and Q I have true, false, true, false. Then P and Q will give me true, false, false, false. So that means this is satisfiable, true for some value and false for some other value, right? Now we will solve now another question, right? Suppose I have question given, prove 1 by 1 into 2 plus 2 into 3 up to 1 by n into n plus 1 is equal to n by n plus 1. I have to prove this, right? So I can prove this using induction. P of 1 will give me 1 by 1 into 2, which is 1 by 2, right? That is 1 by 1 plus 1. So this is true for P of 1, right? N is equal to 1. For P of k, that will be sum up to k, which is k by k plus 1. And for P of k plus 1, that will be sum up to k plus 1 by k plus 1 into k plus 2, right? So this will be k by k plus 1 plus 1 by k plus 1 into k plus 2. So this will ultimately give me, when I will solve this, so this will give me k plus 1 by k plus 2. Hence, this is proved, right? For all n belongs to natural number. So this was all for this video. Now we will discuss next topic in next video.